Hello everyone. In this video, I will be doing a simple derivation of the first principle method in calculus, and by the end of this video, I hope you will gain a clear intuition of what each term means and what are they used for. Finding derivative of a function means to calculate the gradient of a tangent which cuts the circle or a curve only at one point. Now we know that it is hard to do the math with just one point, so we are going to make use of something similar called secants, which cuts a circle at 2 points. Now here I've taken a bunch of secants which are parallel to the tangent. If you notice, we can see that the length of the chord as it approaches to the tangent decreases its value gradually. So the closer we are to the tangent, the lesser the value. Ultimately it ends up at a point here, so the value of the chord ultimately becomes 0. Now to do the math with this thing, we need to make use of limits. Consider this graph here with positive x-axis and positive y-axis, and let this curve be a function of x. So y equals function of x. So what we are after is a gradient of a tangent, and to find that we have to make use of a secant which gets closer and closer to becoming a tangent. So the point we are after lies somewhere between this point and this point. So let's name this point as x and the distance from this point to this point be h. So we can write this point as x plus h. To find the gradient of this secant here, we have x coordinates and we need y coordinates. So let's name this y coordinates as, because y is a function of x, we can write this as function of x. And for this point, we can write it as function of x plus h. Function of x plus h. So we are after this secant over here. So the gradient of this secant m equals the difference in y-axis over the difference in x-axis. So it's just function of f of x plus h minus function of x over the difference in x-axis, which I've defined as h here. h. With this equation here, we can calculate the gradient of the secant. But we are not really after the secant. What we are after is this point over here. And we know that this point lies somewhere between these 2 points. So if we make use of limits and reduce the value of h to nearly 0, we can find the gradient of the tangent. So what we can do here is gradient of tangent equals limit h, which is the difference, tends to 0, function of x plus h minus function of x over h, and hence we have derived the first principle with the help of geometry.